A few years ago, in October 2022, this happened.
For the first time in U.S. history, the Bering Sea snow crab season is canceled.
Snow crab populations had crashed, and officials had no choice but to close the fishery. The next year, it happened again.
For the second year in a row, Alaska's world-famous snow crab season has been canceled.
Fishermen were hit hard, and the whole industry was impacted, from distributors to processors to consumers. And making it all the more confounding was that just a few years prior, snow crabs were abundant.
In 2018, we had seen more crab than we had ever seen in the Bering Sea. So this decline of roughly 10 billion crab with a B from 2018 to 2021 was a precipitous, unexpected collapse.
So what happened?
Yeah, so the collapse really, the story starts in 2018.
This is Dive In with NOAA Fisheries. I'm John Sheehan. And today we'll hear about the collapse of Alaska's snow crab population, the factors that contributed to it, what likely caused it, and why it matters.
In 2021, when we got the survey data, there were no crab out there. And everybody was just like, what is going on now? It was $250 million fishery in 2020 for snow crab. And then 2 years later, that went to zero. So it's been just a massive economic impact for the communities that are dependent on these resources.
This is my guest, Dr. Cody Szuwalski, a research fishery biologist and stock assessment scientist at NOAA's Alaska Fisheries Science Center, and the lead author of a study examining the collapse.
There were basically two levels to the detective process, and the first was to figure out whether or not they moved or whether or not we thought they died.
Spoilers, they died.
Mortality seemed to be the culprit. We started pulling hypotheses out from the literature and crab experts, and we sat in a room and talked about it. And some of the big ones are things like cod predation or cannibalism or disease. There could be indirect fishery effects or temperature effects on crab.
And through their detective work, a lot of it made possible by the years of survey data they had access to, Cody and his colleagues began knocking down causes. It wasn't bycatch or overfishing. It wasn't cod predation. It wasn't disease. But two things did pop out.
The temperature that the crab were in and how many crab were in the system.
In 2017 and 2018, a large marine heat wave had swept through the Bering Sea, raising temperatures.
It wasn't immediately clear what was going on because the temperatures that we saw in the Bering Sea were not lethal to crab. They weren't so hot that the crab were just dying because it was too hot. So we had to turn to some other laboratory studies to kind of build the picture. We had to pull other pieces of the puzzle from other scientists. And one of the big important ones was a study that took crab and put them in different temperatures of water and then measured how much they ate. And from that, we were able to calculate the caloric requirements for the population over time. And the big thing that jumped out here is that from 2017 to 2018, the caloric requirements of the population quadrupled. And this is due in large part to the increase in temperature. Based on that observation, decreased spatial footprint of the crab, so they were in a more confined area of the Bering Sea, and looking at their changes in weight at size over time, we concluded that this mortality event was likely related to starvation.
And this is so fascinating that instead of taking the first condition as sort of the cause, that being this marine heat wave, and saying, well, temperatures are up, but they can withstand that, they should have lived, but then saying, oh, their food requirement was so much higher given the temperature, and looking at the size of the crabs themselves, they were so much smaller, they must have starved.
Yeah, I think it's important to always remember that ecological work in this context is really detective work because we get to observe the population once a year. We go down in the summertime. That's the only time we can get there because there's ice over the Bering Sea most of the other times. It's under 150 meters of water, so I don't get to directly observe these crab dying. So it was a bit of detective work. It was an interesting problem to work on, and I really appreciate all the collaborators and people that helped me and my co-authors get to where we were.
And Cody, in this instance, there was a conclusion. There was you came to the conclusion that it was starvation as a result of temperature, which is, it's not a great situation, but it is nice to have these answers. Can you talk a little bit more about how useful it can be to have answers and to be able to draw lessons moving forward?
Sure. I think trying to answer questions like these is really important to managing our natural resources, because when you see changes in populations over time or abrupt changes, as a manager, you have to make decisions about what to harvest every year or what not to harvest every year. And making those decisions depends on understanding why the populations are changing. And in this instance, we were able to provide some science based on the best information that we've got that suggests that starvation was the role and it wasn't predation by cod or disease. And that can kind of guide your hand in the sorts of decisions that you make.
Does any of this inform models going forward? You know, if you can say ocean temperatures seem to be rising, can you factor in like starvation as a possible outcome?
Absolutely. And I have built models like this and will hopefully publish them in the not too distant future. There are a number of challenges with building these sorts of models. The first and most basic is that a lot of the times we're moving into environmental conditions that we've never observed before. And if you've never observed environmental conditions like you're running into, it's difficult to understand how the population is going to respond, because all of our models are conditioned on historical data to try and understand what might happen in the future. So that's a fairly big stumbling block. Another issue with modeling is these sorts of things is that it introduces a whole number of questions that we haven't had to really consider to this point. One of the big ones is when we should change our management targets. We have targets for how much crab we would like to have in the water and the exploitation rates that we need to apply to get to those. And those management targets are based on the life history of the animals, so like how much they grow, how much they die, how they reproduce. But they're also based on environmental conditions. And if you incorporate these future environmental conditions into your models and it projects the stock is going to go down, it presents very difficult questions about whether or not you should change your targets to follow it down. Because if you follow it down and you change your target, it will let you fish harder than you would if you didn't change your target. And that seems like a counterintuitive response to a population that you're harvesting being stressed by another anthropogenic driver like climate change.
And let's talk a little bit about the consequences of these management decisions. What was the fallout from the collapse we discussed?
Well, I think the immediate fallout from the closure of the fishery was hundreds of millions of dollars not going into communities that usually goes into communities. And this has ramifications just from top to bottom, from tax revenues, from jobs that people have individually, from crabbers making payments on their boats. So it's really shaken up the crab industry, and it's particularly hard in the crab industry because they fish crab and not a lot else. And in 2022, the red king crab, which is the other moneymaker in the Bering Sea in the crab world, was also closed. So it's been a very, very difficult couple of seasons for them.
Yeah, it's really awful. And it was bad enough that the Secretary of Commerce declared a disaster. You know, it was some funding entering the area to mitigate it, but nothing's going to replace the resource.
You're right. The disaster funding has come through, and that will go to help communities in need. And it's also going to fund some research to try and understand what we can do going forward for the crab populations. I think the really hard thing is that in some respects for snow crab, managers don't have the management levers that they need to sustain the population. And when I say that, I'm referring mostly to ice. Like snow crab, as you might guess from their name, like the cold. And the cold comes from the ice in the Bering Sea. When the ice melts, it leaves a cold pool on the bottom where it's nice and cold, and the snow crab love that, particularly as juveniles. The expectation is as the ice goes, so will the snow crab. So I think the big takeaway for me is the increase of these extreme climate events and then just the gradual directional change in temperature over time. The outcome is less certainty in everything. In the short term, that can be things like a collapse from year to year. So we could historically count on We saw X number of crab in the survey last year. We'll probably get 70% of that crab in this coming year will survive, and then maybe there'll be some recruitment on top of that. But we can't really count on that anymore because of the sorts of mortality events that we've seen. So there's just a lot of uncertainty and shakeup of the ecosystems that we're working in. It's challenging.
And finally, Cody, it used to be that a lot of management decisions were based on sort of reining in overfishing, and now it seems like the bigger challenge is trying to figure out how to deal with the effects of climate change, which are impacting these fisheries in ways that you just can't prevent.
Yeah, you're absolutely right. As a fishery scientist, historically, overfishing was the thing that kept you up at night. And that is the thing that a large amount of resources have been devoted to eliminating in the United States. And in large part, we've been very successful at doing that. And we've seen reduction in overfishing dramatically over the last decades. But now it really is climate change that is the thing that keeps me up at night for sure. The assumption that the future is going to be similar to the past is not an assumption that we can make anymore. And if we can't make that assumption, it's hard to make predictions about what will occur. It's definitely going to be the challenge of my generation of fishery scientists in trying to understand how to confront this issue. And I'm happy to be parts of large teams of very smart people that are thinking hard about it, and I'm optimistic for the future.
Well, Dr. Cody Szuwalski, thanks so much for talking to me.
Yeah, thank you for having me. It's been a real pleasure.
Dr. Cody Szuwalski is a research fishery biologist and stock assessment scientist at the Alaska Fisheries Science Center, and the lead author of a study on the collapse of the eastern Bering Sea snow crab. To keep up with the latest science news from NOAA Fisheries and around the agency, check out fisheries.noaa.gov. Or sign up for one of our newsletters with regional news or climate change-focused stories. I'm John Sheehan, and this has been Dive In with NOAA Fisheries.